Welcome, everyone, and thank you for joining us for today's webinar, How Graph Databases Deliver Enterprise-Grade Security. My name is Mara Lee, and I'm part of the webinar team here at Neo4j, and I'm joined by Pat Wall, Director of Product Marketing, and our special guest, Christoph Willemsen, Chief Technology Officer at GraphAware. A few housekeeping items before we get started. We invite you to submit any questions you have throughout the presentation using the Questions tab located at the top of your screen. We'll answer as many questions as possible at the end of today's webinar, and if we don't get to them all, someone on the Neo4j team will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. With that, I'll go ahead and hand it over to Pat.
Thanks, Marley. Hi, everyone. Pat Wall here. Really excited to talk about graph databases with security, and I'm even more excited to be here with Christoph. Christoph is a really big expert in graphs, but he's also a security expert as well, so bringing both his expertise will be really helpful. So, quick agenda. I'm going to go over Neo4j security a little bit, then I'm going to pass off to Christoph to do some security best practices and show live examples of Neo4j. So I like to start off with real-world evidence, showing some areas of how security and graphs are in the real world. John Lambert, he's a distinguished engineer at Microsoft. He talks a lot about security, and one of the things he tweeted the other day was, defenders think in lists, attackers think in graph. And this is so true because attackers look at a network like a graph and say, okay, I can come in one place, but how do I go across this network? How do I find areas where that high value asset is? So I really like using this one. I also like to talk a little about numbers. Every day we're seeing so many more and more data breaches. IBM put together a really great report, and they actually kind of showed how much money and cost and where all these breaches are happening. In the United States, the average breach is $8 million, and it takes 237 days, and it's in the healthcare. When we go across the pond over to England, it goes down to about 4 million. Longer time period, though, of the breach, and that's in the services. And then I thought, hey, let's go see where Christoph is. Let's see how Italy's doing. And Italy's doing much better than both. It's 3 million. A little bit longer time frame of the breach, and it's in financial services. But the whole idea of this is that it doesn't just affect healthcare. It doesn't affect financial services. Data breaches affect the entire world and cost a lot of money. So you want to make sure that your graph database is the most secure with your sensitive data. And so as you're building the next generation of applications using graph, we look at this and we say you need 4 things. You need outbound scale. You need your graph database to scale as your business requires grow. You need intelligence and learning. So you need to bring in data science and machine learning to actually find and reveal context. So find and look at those richness of the data and find that great relationships or those unknowns. And probably most of all, we're going to be talking a lot today, is security. You need to make sure that the most sensitive data is secure so that the right person can see the right data at the right time. Neo4j 4.0 brought out a lot of different security features, and it really made change in graphs. One thing that's really big is granular security. And when we talk about granular security, we're talking about role-based access control, making sure that certain individuals have the ability to write into the graph, others have read, and the right person can see the right data within the graph. The other thing, and this is actually really big in graph, is admin controls. So some other graphs technologies only allow for admin to see everything, so they can do everything. With admin controls in Neo4j, you have the ability to have an admin to just change a password or create a new database without actually seeing or changing in the data. And that's really great for compliance when you're looking at different areas. And when we talk about compliance, we're talking about a wide variety of different compliances. So we're talking about, how we can help you be compliant. One thing is multi-database. So multi-database in 4.0 allows you to segregate data into different databases. You can have your European data in one database, your US data in another, and maybe your Asia Pacific in a different. And they can all work together and collaborate, but they're also very separate, so you can't have any problems within GDPR. So let me show you a little bit of example. So right here, this is a life science graph, but it could be anything. And it could be financial services with fraud. It could be government, a wide variety of different graphs, but this one's about life sciences. And the whole idea is you have so many different data sources. You have, worksheets, Excel, PubMed, Google patents, FDA information. And then you also have all the public sources as well, like academic papers and grants. And so you're bringing all this data into the graph. And you're going to want to say, okay, I want certain people in my organization to see certain parts of the graph and others to see other parts. And maybe some parts be everyone. So what you can do is with that role-based access control is you can actually create, the clinical team. The clinical team can see one section of the graph. And then you can create the rules to have another team, maybe regulatory compliance, see the FDA section of the graph. And so everyone has access to the graph, but they're only seeing different parts. And then finally, you might say, you know what? The patents that are public and all the other things that's public, we want everyone to see that. So you can set up these different permissions and allow different areas within the graph. And it's really important because you're gonna have so many people in the graph working, building, and using this application, and you want to make sure that they have the right information. So without further ado, I'm going to pass it off to Christoph to show some best practices.
Thank you, Patrick. Thanks, everyone, for inviting me. I'm very excited to be here today to speak about security with Neo4j. Actually, to speak best about security, I think that it's great to speak about the STRIDE threat model, which is a model that we use to evaluate the security of a Neo4j deployment. Not only in Neo4j, but in security application. So first, a small introduction to security with that model. So STRIDE was created by Microsoft as part of the process of threat modeling. So threat modeling is part of the secure development lifecycle of application. It helps people to reason and find threats into the system. Generally, it includes a breakdown of processes, data stores, data flows, and trust boundaries. So it's very schema-based. So we actually can do all of this on a whiteboard, right? And it's mainly used by security experts in organization to answer the questions, what can go wrong in the system we're working on? So in secure development lifecycle, you will actually define when you build a new feature or you build a new system, okay, you need a threat model to identify what are the security requirements of that new feature or new system. So if we take a new system, we can take this one. So we have two applications connected to Neo4j and multiple users connecting to that application and doing graph queries. So let's go with that model and identify the 6 categories of STRIDE. So STRIDE is really a mnemonic for security threats. So the S is for spoofing identity. We will go over all of them in quick detail. T for tampering with data, R for repudiation, I for information disclosure, D for denial of services, and E for elevation of privilege. So we actually take our threat model here and try to identify, based on the 6 categories of STRIDE, where are the possible threats and what do we want to do to mitigate them? And or sometimes, also, what do we agree to not act, right? Because threats, security cannot be 100%, never. But you have to document, okay, what you do not want to do. So let's evaluate the security of our Neo4j deployment. Let's take the first category, spoofing identity. So spoofing identity is pretending to be something or someone else, right? So back in the days, it was like applications defining an administrator. If a user was administrator based on a cookie, and you could actually change the cookie or change the session, etc. So in Neo4j, there is some potential for spoofing identity. So to be sure, the definition is really illegally accessing and then using another user's authentication information, such as username and password, right? So if we take the Neo4j browser, if I go to one of my colleagues' laptops and his Neo4j browser is open and he didn't change any setting, I can actually spoof his identity. How? Well, because the Neo4j browser retains user credentials by default in the browser local storage for improving user experience, of course. So, but they actually store this here. You can see, so just open your Chrome developer tools, for example, and you will see that it stores in the local storage the username and password of your Neo4j connection, the Neo4j user. So what you can do to mitigate this threat is to disable the retain connection credential setting. So go to your neo4j.conf file and change the default value from true to the secure value false. Second category is tampering with data. So tampering with data is a malicious modification of data. So let's identify how we can actually modify data that is run between a user and an application or between two applications, right? So Neo4j runs by default on unsecure network protocol, so HTTP or bold. And well, if I actually create a node with sensitive information from my laptop and the Neo4j server is running on unsecure network protocol, and a hacker can actually just use Wireshark here. It's not a fake screenshot. This is actually a screenshot I did yesterday, trying this with Wireshark. I can actually identify the packets running over the network and try to modify it on the fly. In order to mitigate this, we can use Neo4j on a secure network with TLS, not only between the user and the Neo4j server, but if you run Neo4j in production with a Neo4j cluster, you also need to use encryption between the cluster nodes, right? Yeah, and then do not use Neo4j on standard ports. So we all know Neo4j run on 7474, 7687 for bold. Change it when you run in production. Change the default port. Repudiation. I believe it is the most important category in security. So repudiation is claiming that you are not responsible, claiming that you did not do something. So how do we identify the threats? Well, if a user deletes a node from the graph and there is no evidence of such a deletion, or the user deleted the database from the server and nothing is in place actually to trace back the deletion action to the actual person who did it, well, enterprise are then in a serious problem because you have to trace back what happened on your system. Right? So here, if I take that user that used that application that deleted the node in a Neo4j database, well, and another user here that is running on another application that actually rely on that node, well, if something happened, you need to be able to identify which user deleted which node or which database, which impacted how other users are able to do their work. In order to remedy to repudiation, well, first thing, of course, is enable audit logging, query logging. So only enabling query logging for queries that take up a certain amount of time is not really sufficient, right? So we work with clients in environments where logs are the source of truth of what happens in your database, right? So we have to log everything. Of course, it has some challenges for operations, disk space, etc. But really, the cost of disk space is very, very low compared to the loss of the cost of losing data. So yes, log everything. And there is one aspect to query logging that I find a bit sad because it's not really advertised enough in the database world. I would say even in enterprise world, is that it's not only for debugging purposes. So every developer thinks that, okay, logs are great for debugging. it's not only for debugging, it is one of the most important, crucial aspects for security, because this is what forensics will use to when you have an incident. So another aspect is the ability to use transaction metadata from your application. So when you are actually querying or doing operations against the Neo4j server from your operation, using Neo4j official drivers, you can add additional information to each transaction that you perform to the database. I will show a small demo of that later. Right. So this is a piece of code that would actually add information to the transaction. So it would actually log that a particular transaction was run with that additional metadata. Information disclosure. So it is the exposure of information to individuals who are not supposed to have access to it. Right. So, for example, people should be able to see only the information they should. Right. So the receptionist at an hospital might probably not be able to see which particular symptom a patient will have. Right. So this is everything here is based on the principle of least privilege. Right. So people should really have access only to the information they need to. Here, Neo4j did a very great job because you have very, very fine-grained access control in Neo4j, right? Not only to specific database, but also to the ability to read or write to specific labels, read or write to specific attributes on nodes having a specific label, the ability to traverse only particular relationship from a node, etc. So Neo4j really is very advanced in the database world when it comes to to security. Denial of service. So this is the act of denying service to valid users. And here, especially with the introduction of multi-database in Neo4j, well, this can have an impact, right? So if you have a Neo4j server that runs 10, 15, hundreds different Neo4j databases, well, if one user is doing a very, very expensive query, or maybe without intention to do so, but a query that can actually impact the stability of the server because it's requiring too much memory, or would actually put the database down, actually, well, it can affect all the other database on the system, right? So also the amount of connections open to the Neo4j server. So if we take the actual hacker DDoS news that we would find, well, they would open thousands and thousands of connections to a server. Well, this is what happens, right? So the Neo4j server would not be able to handle incoming requests from actually trusted users, because untrusted users would actually saturate the network, right? So, so if we take here, so two users, if application one is doing too many queries or very bad queries affecting performance, it can impact users of application two, right? So in terms of remediation, well, Neo4j 4.1 introduced a very, very nice new control to be able to manage the memory on transaction basis. So it is in the same aspect of the query logs, I will say, is that it's not only for debugging purposes to identify, okay, which query is using what memory, but it is also very important for security to be able to control that a transaction would not be able to actually affect the whole server. So how it works, I will do a small demo later, but it makes an estimation of the amount of memory a query would take, for a transaction would take, actually. And it can be compared against a threshold that you set in your Neo4j configuration. So in case the transaction, the estimation would say, okay, this query is actually higher than this threshold, then the query would be killed or prevented to run. So this is very, very important for the future and the stability of multi-database deployment of Neo4j. Then comes the elevation of privileges. So it is the aspect of having unprivileged user gaining privileged access. This is a very, very advanced scenario because it means that generally people already introduce your system. So it is like a very bad scenario, right? So they would steal username password, or like we've seen in the news recently with Twitter, like with social hacking, right? They would ask to people to give credentials, and then they can actually like extend their footprint in the system, right? So they would actually give them more roles, give them even the admin roles, etc., to be able to have more control on the system. So and then like make much more damage. So in terms of elevation of privileges, well, I would say that again, the logs is the best source that you have to mitigate this threat, right? So you in the security logs of Neo4j, you have logs that print when a role has been assigned to a user. So you can define alerting based on those logs, actually. So we can see here in a Neo4j server, when a user is granted a role, everything is logged, right? So you can define um, uh, like alerting systems to make sure that the right people know what happens on the system. And here is a small output of another log. So this is to show that here we create a node, and we can see in the second line that we see the number of bytes that this transaction is actually requiring. So, and this is very important to have this in the logs as well, because you can, like again with some tooling, identify that users are trying to make a lot of frequent transactions that can affect the stability of your Neo4j server. And who says affecting stability means affecting how users can access information. So I will do a very, very small demo. Let me share the screen. Right. I am here in Neo4j for that one, and I have a patient's database. So here I am connected with the administrator user, so I have access to everything. So we have patients. Here I have one patient, John. Let me zoom so it will be clear for everyone. So I have one patient, John, in my database. I can expand the patient and see that this patient has a disease, cancer. Right? And I have access to all the information about that patient. So I have access to his name, and I have access to his date of birth. Right? So if I would be logged in as a different user, so for example, I can show the users of my Neo4j server, of course, the system, show users. Yeah. Right. So here I have John, Neo4j, Smith, Weston, Willie. Right. We can see here I have a user who is a doctor, and I have another user who is a researcher. Right. So we can determine that doctor has access to primary information, and researcher for research purposes might have access to additional information. Right. So what I will do is that I will connect with another user. Right. Server disconnect. And I will log in with the user Smith. Now I have access only to the patient's database here, and I can see I have a patient, but I'm a doctor. I don't have actually access to the date of birth of that patient. However, as a doctor, I should of course see what are the diseases that this person has. If I would log in as a researcher, I have access to the same patient's database. And now, if I search for a patient, I have access to the date of birth and job. Right? Potentially, I can create a node, a new patient as a researcher. If I would try to do the same with the Dr. Smith, I am denied rights on the database. So as you can see, Neo4j has a very fine-grained aspect to when it comes to reads, but also writes to the database. So this is very important because making you a full demo of the capabilities of every single rule that you have would be very long. So I invite you to go to neo4j.com and search for fine-grained security, because Neo4j can handle really everything, be it also for DBAs, so making sure that DBA people can only manage schema, creating new databases, etc., and actually cannot have access to the real data of the users. So I want to show another feature of the last Neo4j 4.1, which is making sure that transaction cannot affect the stability of the system. So what I will do is I will here log back again with the Neo4j user, because then I can do everything. And I will run a query here. I will try to run a query that wants to write 1 million nodes in the same transaction. Right? So you can imagine that writing 1 million nodes would require much more memory than making a simple match, finding a person. Right? So, but I configured Neo4j to make sure that my transaction can only require 2 megabytes of memory. Right? So if I am actually trying to do this, well, the Neo4j server is actually telling me that this transaction will require more memory than the limit I have configured in my Neo4j server. So I am actually sure that trusted users will always have an available Neo4j to be able to do their work, right? So the availability of your Neo4j server is also part of security, right? Now let's do the last part of the demo, which is showing how locks are important. So I will make a simple write to Neo4j from a application, right? So here I will run that mini program, and it will write data to Neo4j, right? So we can see here that I have a transaction where I have created a node, okay? But there is not much more with that information, right? So if I have those, not thousands, but let's see, tens or 20 applications running in the same Neo4j server, well, I would be very interested in having more information, right? So as I explained before in the talk, we can add additional information from the application. It's very important. So in our traditional application, we even use the security context of the application itself. So we can even pass to Neo4j which user in our application did which transaction. So here I can say, okay, my application is security webinar and the scope of this application is test. right? So if I actually would run that mini program, I can see now much more information that would be useful to me if there is an incident, right? So if there is an incident, I have all the information I need to trace back that incident to a particular application or to even a particular user in a particular application. So this is the end of my demonstration. And I will go back to the slide.
Thanks so much. That was really great. It was awesome to see all different aspects of Neo4j working together with security. Really appreciate it, Christophe. I think we have some time for questions.
Hi, Pat. Hi, Christophe, and thank you both so much. That was a great presentation on security. And yes, we do have some questions that have come in, and I want to remind the audience if they have a question, they can submit it using the questions tab located at the top of their screen. If we don't get to your question, or if you have another question, you can always send it to webinar@neo4j.com, and we'll make sure to get that over to Pat or to Christophe, or as you see there, information is on the screen right now. But let's get started with the questions we've received. Here's one that came on early on and several times, and it's about where can I learn more about Neo4j security?
That's a great question. There's a lot of different places in Neo4j to learn about security. First, I would look at the database page, Neo4j database, and actually there's a whole section on security. Also, if you want to go a little more hands-on, developer focus, we have a really great community that has a ton of different documentation on security. And then finally, I would look at, there's a new e-guide out called Why Intelligent Applications Need Graph Databases with Granular Security. I would take a look at that. It's a pretty great guide for security as well.
Great, thank you so much. And this one, I guess it would be for both of you. Do you have some examples of security use cases?
Yeah, I can answer this definitely. So in terms of use case, so where we see enterprise customers use to the best the Neo4j security features, of course, I would say that everything that comes down to law enforcement is a great use case for using Neo4j security features. And yeah, because even the public want to, I would say, so you don't want people to search for other people just by interest, right? So it should be part of their job. So again, this is why logging aspect and repudiation is very important in that use case. And yeah, I would say that as a graph itself, even identifying your own application security by using a graph is really awesome, right? So if I have an application that uses permissions, roles, etc., also storing everything in a graph is super easy and gives immediate insights to part of your application that are insecure enough, or where there is actually spotting that there are too many users having access to certain parts of your application. Thank you.
No, I think I totally agree, Christophe. I think there's also a lot of other great use cases as well. Neo4j.com customers has a ton. I mean, we have customers like the U.S. Army, NASA, many of the top banks and pharmaceuticals use Neo4j, and they use security features because they're bringing very sensitive data into Neo4j to do some in-depth analysis. And so I think there's a ton of great use cases as well on Neo4j using security.
Great, thank you. And it looks like we are running a bit tight on time and a little bit over, but there's this one question that came in, Christophe, that I want to give to you, and it's about single sign-on, and it's asking if GraphAware supports single sign-on.
It's a good question, thank you. Well, yeah, of course, our application use single sign-on. But I think that most of applications on the market you have to use single sign-on. But how can we leverage single sign-on even for the Neo4j server? So we actually created a Neo4j security plugin for Keycloak, right, which is a identity and access management server sponsored by Red Hat. So this means that we can actually use Keycloak to federate LDAP and connect Neo4j to Keycloak, which has a lot of benefits, because one of the most threats to security is a misconfiguration that you have of your server. So if you have to configure LDAP in neo4j.conf, it's not really straightforward. It is very prone to error, actually, because it's very string based, right? So we actually solve this for some companies by being able to leverage single sign-on for Neo4j for our application. So actually, yeah, security everywhere. So this is, and graphs, of course, but yeah. So yeah, we do support single sign-on on both sides, application and Neo4j server. Right.
Oh, great. Thank you for that explanation. So we are about out of time. I want to thank Pat, and of course, I want to thank our guest, Christophe. Thank you so much for being with us today.
Thank you.
And I also want to thank the audience for joining us. And with that, I'm going to wish you all a great day. So thanks so much.
Thank you very much. Have a great day. Bye-bye.